Okay, in a previous class, I was discussing last but one topic, that is communications criteria. This is the last but one module topic of second module. Okay, after this topic, one more large big topic is there, that is 2.6 IoT access technologies. Okay, so briefly, already I have given a brief summary or introduction about these two topics, communications criteria as well as IoT access technologies. Here we are going to see some criterias or attributes or characteristics of communication protocols and other devices where we are using these devices in IoT networks. Okay, so first parameter or criteria was range. So we divide this range based on the area. Okay, based on the area up to which they are able to send the signal. The first range we categorized as a short range, medium range, and then long range. So if your range is a short, then we can use this technology, that is Bluetooth. If our range is medium, then we can use this Wi-Fi technology. Okay, then if our range is a long range, then we can use these cellular technologies. Hmm. So these all things already we have discussed, short range and what will be the distance between two devices. Okay, so these all things we have discussed. Next, let me to go to one more subtopic today, that is one more characteristic or criteria, that is frequency bands. So as I already told, frequency bands are nothing but they are the strength or strength of signals, which are radio signals. Okay, so here which bands are available for us for communication? These all things we will see here. So radio spectrum is nothing but a radio wave or a radio signal. Okay, so these radio signal is regulated by countries or organizations. It means that somebody should be there to control us, right? So somebody should be there to regulate us, even though we are if we are out of control, somebody should be there to control us or to regulate us. Regulate means increase the speed or decrease the speed, right? Increase the activities or decrease the activities. So it means that continuously who is going to take care of these radio signals, under whom these radio signals are controlled or regulated. Some countries are there, countries are regulating them, and also inside those countries some organizations are there. They may be private organizations or they may be government organizations. These organizations are controlling or they are managing these radio signals or radio waves. Okay, so which organizations are controlling them? So ITU, International Telecommunication Union, and one more organization is there, that is FCC, Federal Communications Commissions. They are putting the rules on these radio spectrum usage. So for this much usage you have to pay this much, for this much usage you have to pay this much. Like this they have maintained these radio signals very properly. Okay, so these organizations define these regulations. Okay, so these organizations, they put regulations and rules and some other constraints or conditions on these radio spectrum. Okay, these are going to define some regulations as well as transmission requirements for various frequency bands. So for particular frequency band, what will be the requirement to transmit the data? These are nothing but transmission requirements. So these organizations will set these regulations and transmission requirements for these frequency bands. For example, some part or some portion of these radio waves. So like our bandwidth, the entire bandwidth we will not use. So if a bandwidth is dedicated to you, then you will be called as a broadband or something, right? So in broadband we are dividing the bandwidth, and then a particular bandwidth is allocated to some particular person or device. So like this here also, in these radio spectrum or radio signals, some portion of these spectrums are divided and those are allocated, or they are given to some different types of telecommunication applications. Like it may be radio, it may be television, or some military applications, like just one example I have taken as a walkie-talkie here, and other any communication which is used in military. For these all applications, these frequency bands or these spectrums will be divided and they will be allocated to each and every application. Then we can see the values of these frequencies by looking into this cost that mobile operators pay licenses in this cellular spectrum. See, we will get the values of these frequencies. We will get the importance of these frequencies only when we start to pay so much amount of money to the cellular service providers. So it means that you can see, so for just telephone communication on your mobile phone, so since they also need signals, right? So we have to pay to some service providers like Airtel, Jio, and so many, right? So why this is this much costly? So why that recharge packages are this much costly? Because of these availability of frequencies. Okay, availability of frequencies and more number of usages. Then if more number of usages are there, sorry, excuse me. If number of users are more and the frequency is some specific frequency, and that specific frequency has to be divided and it has to be allocated to each and every user, so that it can be every user can be satisfied and every user can be serviced. Okay, so because of that only we will come to know the importance of these frequencies only when we pay lot of money to these services. So just example I have taken as a cellular spectrum. Apart from cellular spectrum, there are so many other services also we use. Okay, then focusing on IoT access technologies. Focusing on IoT technologies, the frequency bands. When we go to next topic, as just now I told you, next topic is what here? IoT access technology. IoT access technology is nothing but the technology or the media or the physical medium which is going to connect two devices, and it is going to make a network of devices in a particular topology. Okay, just remember, IoT access technology is nothing but a medium. It may be wireless or wired. So these technologies, when we focus on these technologies, which is the next topic, the frequency bands that are purchased by wireless communications are split between licensed and unlicensed. It means these frequency bands, whatever I am discussing now, frequency bands are categorized into licensed and unlicensed. Let us see what are licensed signals and unlicensed signals. Usually, these licensed signals, licensed spectrum, it is applicable to IoT access technologies, or they are going to be used in IoT access technologies, particularly which want long range of communication. Are you understanding? So when we should use these licensed spectrum, when we want to connect two devices and those two devices are completely in a remote area with a long distance, so at that time we can use these signals for access technologies. Are you understanding now? So this is the first step. Next step is IoT access technologies. Next topic is IoT access technologies. If you want to use those IoT access technologies, in those IoT access technologies, you have to use these licensed signals if your devices are so long away. Okay, so for long range of for long range of communications in IoT access technologies, we use these licensed spectrum. Okay, so then these spectrum is allocated to communications infrastructures. Communication infrastructure is nothing but your network and network devices, so which are deployed by the service providers, public services. For example, the first responder. First responders will be usually military and any rescue team. Okay, so it may be your fire station, military, and any other hospital and any ambulance. Okay, so these all are emergency services are there. No, we call them as first responder. So first priority we are giving to these type of users. Okay, public services. So though, so these public services are using a licensed spectrum. Why? Because even though the devices are so long away, so the signals should be delivered properly between those two uh, uh, devices. It means the communication should be proper. Communication means they should exchange the data very efficiently. Okay, so then the broadcaster and utilities in so many uses, we will use these licensed spectrum. Just try to understand in which areas we can use this licensed spectrum. Okay, so the areas where we want long range access. Okay, in such kind of applications we use this licensed spectrum. So even the users who want to use these licensed spectrum, they must have to subscribe to the services first. Then when they are going to connect to the IoT devices, they have to first subscribe. Then it means they have to purchase or they have to pay to the services whenever they are going to connect to the IoT devices. And these all things, whatever I told you, licensed spectrum, this feature is going to add complexity to our deployment. Deployment is nothing but implement where you are going to use those devices and how you are going to use it, how you are going to implement it. This implementation or deployment, it is nothing but installation of devices. It may deployment is nothing but use of these facilities. So it may be installation of the devices and next usage of that devices. Okay, so this will become complexity because large number of sensors and other IoT devices are day by day connecting to our network or adding to our network. But even though more number of sensors, more number of IoT devices are adding, keep on adding to our network, in return, definitely we cannot deny these sensors or IoT devices. Hey, you cannot join my network, you cannot be added to my network. We cannot say like this because everyone should be serviced and everyone should be satisfied. Okay, so what to do now? Now with in return, if you want to add your sensor or IoT device to your network, then definitely you are paying something there. Because of that only you are able to add these IoT devices or sensors to your network. I hope you are understanding. Okay, because otherwise what would have been done in today's days, because of more number of users in a geo network. So these all geo networks, that geo company cannot deny to join them. Okay, so all users should be satisfied. If the number of users are keep on increasing, definitely the demands and frequency and bandwidth and the signal strength will be also should be increasing. So because of that only they may uh, charge us a lot of money. So because of that only, since you are giving money, then definitely you expect that you should be serviced in a good manner. It means that you should not be compromise anywhere in the data signal or any other criterias of that service. Okay, so here sensors and IoT devices, day by day they are keep on increasing in number in our network, but in exchange for the subscription fee, so the network operator can guarantee the exclusivity of the frequency usage. It means that since you are paying something to the service provider, he will guarantee you to give you the extremely best service. Okay, so because of that only, whenever you get a connection to your TV, even if you consider your DTH service, if you take, okay, or else if you consider your any fiber connection to your house. Okay, so whenever you go for such kind of services, so definitely they promise you that we will not get any interruption, you will not get any problem, you will not get any issues. So we will get even though you get a issue, immediately we will come and solve it. This type of guarantees and promises the vendors will do, right? So because you are paying them, so they guarantee you that they will give you the good service, right? So then because of that only, they are going to give you guarantee of a frequency usage over a target area, and therefore they can be sell a better guarantee of service because you are paying them. Okay, then examples of these licensed spectrum are usually in our IoT access technology, what we will use these license spectrum. Now, I am going to tell you the examples for these licensed spectrum now. So first one is a cellular. Okay. So for cellular networks, we should have a licensed spectrum. Then WiMAX and narrowband IoT, that is NB IoT technologies. These are some technologies where we use licensed spectrum. Okay. So then ITU not only has defined the licensed spectrum, it has defined unlicensed spectrum also, which is the second type. Okay, for them we don't need to get a license, okay, from any organization or any country. So these type of spectrum are called as unlicensed spectrum. So these spectrums are used basically for industrial usages or scientific usages and medical usages. So altogether we will call them as ISM. ISM. It means these are the three main areas where we use unlicensed spectrum: industry, scientific, and medical. ISM portions of the radio bands. Okay. So these frequencies, which frequencies? Unlicensed frequencies. Okay. Unlicensed frequencies are used in many communication technologies like short range devices. This is the main difference between licensed and unlicensed. Licensed spectrum, if you want to use, you can use it only when you have a requirement of long range distance communication. Okay. So if you have only short range communication, then you can use unlicensed. Specifically, we use them in industries, scientific and medical. Remember it. Okay. Then unlicensed means that there is no any guarantee for you about a service. Okay. There is no any protection to your communication. Okay. There is no any security to your data transmission. Are you understanding what I am telling? So unlicensed means since you have not licensed, there will be no any guarantee of service, and there will be no any guarantee of security of communication or data transmission. Okay. So then for IoT accesses, these are the most well-known ISM bands. So what are those bands? So 2.4, it means bands means what? Frequency band, right? So in ISM, that is industry, scientific, and third one is medical. So in these applications, what usually frequency we use is 2.4 gigahertz band. Okay. So which is a Wi-Fi. Then IEEE 802.151, which is a Bluetooth, and IEEE 802.15.4, which is a WPAN. So if you observe these all terms, the Wi-Fi, Bluetooth, so these all technologies usually we use in a short range distance, right? So only when you want to use a licensed spectrum is if your requirement is long range communication. Just keep it in your mind. Okay. So these all are unlicensed spectrum. Unlicensed spectrum is usually simpler to deploy. It means it is very easy to implement or install because it does not require any service provider. It does not require any service provider. You install it easily. Because of that only, when we use Wi-Fi in our college premises also. So just one vendor will come and who is selling the Wi-Fi devices, he will come and install the devices or deploy or fix the Wi-Fi devices. Then it is up to us to connect it to the service provider like BSNL or Airtel or somebody else. Okay. So here it is very easy to deploy here. Even in Bluetooth also, no any third person will come and help you to install the Bluetooth. Okay, you can manage yourselves. So implementation or deployment is very easy in unlicensed spectrum. So because of that, it can suffer from more interference. Since it is unlicensed and it is a deployment is easy, so but this type of signals may be interrupted or they may be disturbed from other signals. So why? Because the other devices also competing for the same frequency in a specific area. So obviously the other devices, if they are using a licensed spectrum, then definitely they will get the higher priority and your connection will be lost and those devices will start to use the frequency. Okay, in the same frequency, in the same area or in a specific particular area. So these type of unspectrum signals will suffer from interference. Interference is nothing but somebody will come and they will occupy the place than you. Okay. So then in usually this point is also very important. You should write in your answer. So you should not neglect it. For indoor applications or deployment inside your building, okay, inside your building, and for outdoor deployments outside of your building, okay. So for such kind of applications, we may use one more frequency band, special type of frequency band, that is sub gigahertz frequency band. So first we studied licensed, then unlicensed, okay. Then we are studying now sub gigahertz frequency bands. What these sub gigahertz frequency bands will do? They allow greater distances between the devices. It means that these are also almost belonging to licensed, and these frequency bands will allow us to communicate between the devices which are very long away. Okay, so it means that these sub gigahertz frequencies also provide a long distance communications. So for particularly indoor deployments and or outdoor deployments. Okay, so here some examples for these sub-gigahertz of frequency bands are 169 megahertz, 433, 868 megahertz, 915 megahertz, 868 and 915. Okay, so these all are, if you observe here, so our other gigahertz, other, if you want to compare them with other frequency like 2.5 gigahertz. So if you observe here, it is in terms of gigahertz, but it is in a mega. Okay, so this giga is higher than mega, right? So because of that only, the frequency bands which are divided again, and they are using for some particular any applications like indoor applications or outdoor applications, then we can use this sub gigahertz, because they are using very less amount of frequency for those applications. Okay, so these have a better ability than the 2.4 gigahertz ISM band to penetrate a building infrastructure. Just to see the beauty of these signals or bands. So even though they are using less frequency, they are more powerful than 2.4 gigahertz. Okay, so even though they are using less frequency, they are more powerful than these gigahertz. For what purpose? In which terms? In terms of penetrating the building infrastructures. It means that it will it will pass through the any strong wall or any glass door. So something, so some obstacles if we are using in a building from outside of the building, so those signals will easily enter into that building by passing through the walls, glasses and any woods. Okay, wood material, so whatever it may be, or any metal equipment they may be. Okay, so easily these signals will pass through these all materials inside the building and go around the obstacles. It means that obstacles, they will pass easily through these obstacles while keeping the transmit power within the regulation. It means that even though they are penetrating through these walls and all those other obstacles, but they will not compromise in the data transmission. Whatever the constraint was there, whatever the capacity was there for them, they will definitely give that much of data transmission. Okay, so the disadvantage of these sub gigahertz is only uh, frequency bands is their sub gigahertz frequency bands is their lower rate of data delivery. The one disadvantage is they have a less data rate or lower data rate. It means that in a particular time unit, it means per second, they will transmit a very less amount of data. So apart from this one, they definitely very much strong to pass through the any obstacles of a building. So for such kind of applications, you can use these sub gigahertz bands. It means that even though the data will be transmitted very slowly, but that data should reach its destination device, even though that device is in a base or somewhere in the interior of a building. So even though the device is in completely in interior place of a building, that signal will be definitely signal will be definitely reached to that device. Okay, but one disadvantage is the data rate may be lower there. Okay, in such applications, you can use these sub gigahertz frequency bands. Most of the IoT sensors do not need to send the data in a high rates. See, so that only I told you. Most of the IoT sensors, they don't want to transmit the data in a fast speed or highest rate. So some sensors need a very low rate of data transmission, but that data should reach that destination device, wherever the destination device is located. So for such kind of applications, we can use these sub gigahertz frequencies. So best example, if you want to consider in most of the European countries, so in fact, this is a very small sub gigahertz frequency band it is, which is 169 megahertz. Okay, so this band, see, just it is a 169 megahertz band, which is considered as a best suited for wireless water and gas metering applications. See, in metropolitan cities nowadays, you are not going to carry the cylinder till your floor in the apartment. Okay, you will put that gas cylinder inside the base ground floor, and from that ground floor to your kitchen there will be a one pipe connection, so you will be connected to access the gas. Similarly, so nowadays you can observe in your corporation taps, water taps, which are supplied to your house. Okay, so they are also nowadays they are putting a water meter. So based on the usage of water, you can pay the money. Okay, so for this type of water meters and gas meters in any apartment, and these meters, your device may be a gas cylinder, or the device may be your tap. So okay, these all devices, the equipments may be equipped with one sensor or something. Okay, so since this sensor is in a kitchen, and how much gas you are using, if that gas agency want to know, then that gas agency easily it can read the data of your gas sensor. Okay, so since these sensors are inside your building in some unreachable locations inside your apartment, like any kitchen or any small congested areas, till that sensor if that gas agency wants to send the data through from their office, so that signal can be easily reached that sensor inside your apartment, and they will easily get the readings of your gas meter and water meter. Okay, so because of this, in Europe almost all people believed that 169 megahertz band is a best suited for wireless. See, it is a wireless and wireless water metering and gas metering applications. And this is due to its a good deep building basement signal penetrations. Since these signals may transfer the data in a slow rate or a lower rate, but definitely that data will reach to the sensor wherever that sensor is located inside the apartment or building. Okay, so it may be basement of your apartment, or it may be in the kitchen of your apartment. Okay, so till that sensor, the signals will be definitely, confirmly, guaranteedly they will be delivered. Okay, so because of that only, these sub gigahertz are also playing very much important. Okay, so just see three types of bands here. This is licensed, unlicensed, and then this sub gigahertz. Okay, next let us go to power consumption. Power consumption is also one criteria for communication. This is also communication criteria. So these communication consumption here, in our network, we are going to divide the nodes into two categories again: powered nodes and battery powered nodes. Powered nodes means what? The electricity supply. Okay, then battery powered means obviously the nodes are operated by battery. So a power node has a direct connection to the power source. Obviously, as its name itself is a powered node, right? Powered node has a direct connection to a power source. Then that easy of deployment of these power nodes is limited. It means that, so the only one disadvantage of powered node is the deployment may be difficult in some situations. In some situations means in which situations the availability of a power source. Availability of power source. For example, if you want to keep your laptop or your mobile on a table and you want to continuously work, but what the problem you may face is nearby switchboard you may not get. Okay, nearby switchboard you may not get. So this type of problems you may get. And if since these are powered nodes, so these will make this mobility also more complex. Mobility means you can carry the device from one place to another place. So this is also becomes very challenging. Okay, so this is the disadvantage of powered node. So ease of deployment of powered nodes is limited by the availability of power source, and which makes this mobility more complex. So wherever you want, you cannot take your device. Inside your building, you should be, and also you should be very near to your power board. Okay. So then battery powered nodes bring much more flexibility to these IoT devices, because since the nodes are operated by battery, the best example is your smartphones or mobile phones. Okay, so battery powered nodes are flexibility to the IoT devices. So these nodes are often usually classified by the required lifetimes of their batteries. Just remember, in power consumption already we have divided the nodes into powered nodes and battery powered nodes. Then again battery powered nodes are divided into many types of nodes based on the lifetime of a battery. Okay, what I am telling, are you understanding? So based on the lifetime of a battery, again we are going to categorize these battery powered nodes. Okay, so whether was a water meter or gas meter. Okay, so just now in previous topic I discussed water meter and gas meters, whether they require 10 or 15 years of battery life or what. Okay, so you should first understand this one. Based on that, based on the requirements of those nodes or devices, you can fix the battery there. Okay, and whether 5 to 7 years of battery life is sufficient for some devices. Okay, which are used in a smart parking sensors. In a smart parking sensors also we will use some batteries. So whether if they are giving you the battery life of 5 years or 7 years, is it okay for you or what? You should understand based on your requirement, because maybe after 5 or 7 years your parking area may be renovated. Okay, renovated. Okay, so because the if you are having a parking area in the streets, parking area sensors in the streets, for every 5 years or 7 years, so the parking areas and entire the road or street may be renovated because of a smart city or some anything. So widening of road and some any other construction works. Okay, so if at least if they give you 5 to 7 years of battery life, then there will be no any tension for next 7 years. That is nothing but for a next any construction plans of the city. Okay, so then for devices under regular maintenance, the devices which require daily maintenance or regular maintenance, so a battery life of 2 to 3 years is one best option. Okay, so the devices which need a battery regular maintenance, for such kind of devices we should use the batteries which will give us the battery life about 2 to 3 years. Okay, so we have categorized nodes like this. So 10 to 15 years, that is long battery life, then 5 to 7, then 2 to 3. Okay, so IoT wireless access technologies, what is the next topic? Okay, again and again I am using this word, just remember IoT wireless access technologies must address these needs. It means these access technologies should first understand these requirements or needs, and needs may be low power consumption and connectivity for a battery powered nodes. Not only battery powered nodes, requirements of battery powered nodes, they are also taking the requirements of power consumption also. Okay, so by taking these all things, these IoT wireless access technologies should decide which battery I have to use if it is a battery powered node. Okay, or if it is a powered node, then how much amount of low power consumption is required, or medium power consumption is required, high power consumption is required. So based on these, they have to decide which node they have to use. Okay, so then this has led to a evolution of a new wireless environment known as LPWA. LPWA is nothing but low power wide area. Okay, so because of this IoT wireless access technologies, based on this powered and battery powered and low power consumption, high power consumption, based on these all criterias, okay, based on these battery life of these all nodes. So um, this advancement uh, was a reason for this type of areas like low power wide area. You can see here low power, its name is a low power, it is consuming less power, but wide range, wide area, it means it is supporting a long range. Okay, low power wide area. And obviously it is possible to run or use any wireless technology on the batteries. We can use any wireless technology. Okay, so however in reality, but one disadvantage is, in reality it is not possible to use these battery powered nodes more, because uh, so for every year, or for every month, it is very much hectic for us to replace the hundreds of batteries. Okay, because of that only it is better to use a powered nodes. Okay, so you just imagine in any one company or somewhere else, if the sensors are using batteries, and if the sensors are installed on the same day, or same day, and those batteries may run up to 5 to 7 years. Okay, so then after that, if you have to replace the batteries, you will replace it. At that time, what you do, you may add some more sensors to your network after some years. Okay, so then what happens, then the battery replacement will be not on a particular fixed intervals of years, like every 5 years. Okay, so some in sensors are newly added after 1 or 2 years, right? So those sensors batteries may be replaced after again 1 or 2 years. So like this, for again and again, replacing the batteries will be a hectic. Okay, this is one disadvantage about these battery powered nodes, that's all. Okay, then topology, let us go to topology, which is already, this is the general layout of your network, right? So among these all access technologies, what I am going to use in the next topic, okay, these all technologies available for connecting the IoT devices. Just remember, again and again I am telling you, this IoT access technology is nothing but these are the media through which we are connecting the devices. Okay, so these access technologies are available for us. Okay, why? They are available for connecting the IoT devices. We use these access technologies to connect these IoT devices together. There are three main topologies are there. The topologies are again divided into here three topologies. One is a star topology, second is mesh topology, and one more is a peer-to-peer topology. So these are actually dominant topology. It means most commonly used topologies in our IoT network. So of course there are so many other topologies are there, but particularly most commonly used topologies in our IoT networks are star, mesh, and peer-to-peer topologies. Okay, for long range and short range technologies. Okay, both for long range and short range technologies, a star topology is suitable. Okay, it means that star topology is very much flexible. It can be used for short range communication also, or technologies, or it can be used for long range technologies also. Okay, so for example, you can use this in cellular and LWPA. Just now I told you what is LPWA, that is low power wide area, low power wide area, and Bluetooth networks. Okay, so this is a Bluetooth network is a short range, and cellular is a long range. For every range, we can use this star topology. Okay, star topology is use a single central base station. I think you know the topology of star. Okay, star topology, how it looks like. It has one central base station. Okay, so base station and the remaining endpoints will be there, which are connected to this central base station. Okay, so then medium range technologies, uh, a star topology, peer-to-peer topology, or mesh topology is a common. So for medium range technologies, again star topology is suitable. See, because of that only I told you star topology you can use in the long range, you can use in medium range also, and you can use in a short range also. Okay, particularly for medium range, peer-to-peer or mesh topology is a most commonly used topology as shown in the figure. Let me to show this figure. This is a star topology. Okay, this is a star topology and this is the mesh topology and this is a peer-to-peer topology. So if you want to explain about these three topologies, you just remember our college example only. See, just I take one example here. Nothing is here. Here one central base station is there. Okay, to this central base station, all endpoints are connected. Okay, if you observe in this diagram at the bottom of your diagram in the right side corner, so these nodes, whatever I am showing here, these nodes are the devices which are working fully. Okay, it means that they have more workload. So full function devices. And these nodes, whatever I am showing here, these are reduced function devices. The workload is less here. It means that why sir you told that our college example, because if you consider this star topology, just for your understanding purpose I am telling. So if you consider these all nodes which are reduced function devices, so if you consider them as a faculty and this one function device, full function device, then this node may be acting as a head of the department in a department. So just remember, whenever star topology comes in your mind, just remember that it is a like a department. And whenever mesh topology comes into your mind, just compare it with or analogy it with a college. Okay, and whenever peer-to-peer topology comes in your mind, you can analogy it with a university. So just observe this diagram, then you can easily draw the diagram and you can easily explain these topics. The star topology, just now what I told you, it is just like a department. In department, one head of the department will be there and remaining the faculties will be there, right? Similarly, mesh topology, if you compare it with your college, so each department is connected here to the college. Okay, so every HOD is connected with the other HOD and every HOD is connected with the principal and the dean, right? So this you can consider it as a entire college. And again, these are, if you consider here as a principal, these all different college principals are connected to a vice chancellor of a university. So like this, if you observe this peer-to-peer topology, all devices are full function devices only. Okay, so in mesh topology, there are combination of full function devices and reduced function devices. And in star topology, the number of full function devices is only one and reduced function devices may be many. So because of that only I told you all endpoints are connected to a central base station. Similarly, such type of different star topologies are connected to each other, then it is going to make a mesh topology. Just understand here, mesh topology is not a new topology, it is not any different. It is a connection of collection of star topologies. Okay, so you take these all n number of star topologies and then you just connect them to each other, then it will become mesh topology. Okay, so then here also, if you connect only full function devices are more here and only one reduced function device is there, then it is called as peer-to-peer topology. Okay, so here within 2 minutes this meeting may end. So I would like to wind up the class today here. Once again in the next class onwards, I start explaining these topologies, then we will go to next topic. Okay, please attend the next classes without bunking the classes. Okay, uh, then you can leave the meeting now. We will continue in the next class.